Okay, now we're going to talk about formula mass. We've talked about atomic mass and molar mass. Atomic mass is the mass of an atom. Molar mass is the mass of a mole of something. So formula mass is the mass of an individual molecule or a formula unit. It's basically, look at the formula of the compound, how much would one piece of that weigh? Sometimes called a molecular mass or a molecular weight. And it's just the sum of the masses of all the atoms in that formula. So the number of the first element times its atomic mass plus the number of the second element times its atomic mass, etc. Let's calculate the formula mass of calcium nitrate. This is not a good exam question because if you don't know your nomenclature, then you can't do the question, right? So I don't like to put too many things together on my exams. I save that for the written questions at the end, where yes, I will try to trick you, but the rest of them I'm trying to make straightforward. So first we have to figure out what calcium nitrate is. And we've talked about this, so I'm not going to belabor the point. But for calcium, the symbol is Ca. We find it on the periodic table. It's in group 2, so it has a 2+ charge. And nitrate is a polyatomic ion containing nitrogen and oxygen, and that's the formula because you memorize what it is. And so the formula for this compound is 1 calcium and 2 nitrate ions. If we're drawing these and thinking about how can these add up to have a 0 charge overall, we're going to need 2 of these guys. Okay, calculate the formula mass of this formula. Very fair exam question. So in this formula, how many calcium atoms are there? There's 1. So I have 1 calcium atom, and how much does each calcium atom weigh? If you look on the periodic table, and I'm just going to round them to 4 significant figures because that's what there are on the periodic table in my head, 40.08. Remember, 4 sig figs is the fewest number of digits you should use for atomic masses. You can use more, absolutely. Never less than 4. Okay, so that's the calcium. And then we have nitrogen as the next element. How many nitrogen atoms? 2. And the mass of 1 nitrogen atom is 14.01 atomic mass units. And how many oxygens? 6. Each oxygen weighs 16 atomic mass units. The 2 outside the parentheses says I have 2 of everything in here. So that's 2 nitrogens and 2 times 3, or 6 oxygens. And my calculator's going to say 164.1 atomic mass units. Is that the correct number of sig figs?
Yeah, it's 4.
It kind of depends on how you look at it. If someone had 4 there because these were all 4, I'd say good enough. But if we just bypass the multiplying part because that's messy, and we think about, well, what if we were adding these? I'd be adding this number and this number and this number, and then I'd add this one in 6 times. All of those numbers have 2 decimal places. So when I add them up, it should still have 2 decimal places. So ideally, we'd put a 0 there. The reason I want you to always use at least 4 significant figures in your molar masses or atomic masses is because most of the time the calculations we're doing on problems or even in lab are going to end up with at most 4 significant figures. We don't want our molar mass to be the thing that limits the number of significant figures, because we do know these masses to more precision. Okay, so just write down whatever your calculator says. It's only going to give you maybe 1 or 2 extra digits, if any at all, and just go ahead and use it, and then you can just ignore how many sig figs the molar mass has. Yes? Yes, I can. So 40.08 plus 2 times 14.01 plus 6 times 16. I'm still getting 164.1. So 164.10 AMUs. So it's the formula mass. We talked about molar mass of an element, the mass of 1 mole of atoms. Molar mass for a compound is the mass in grams of 1 mole of molecules or formula units. It's going to have the same number as the formula mass. It's calculated in exactly the same way. So what is the molar mass of ammonia? What do we need to know first? The formula, right? What's the formula for ammonia? It's NH3. There's a polyatomic ion that's very similar to this, ammonium, and that's NH4+. And they are related to each other. But this is ammonia. And so, like I said, I will try to trick you with ammonia and water. You should know those formulas. So the molar mass, here we're talking about 1 mole of ammonia. So in 1 mole of ammonia, how many moles of nitrogen? Just 1. It's just like looking at the formula. There's 1 N in the formula, so there's 1 mole of nitrogen. And each mole of nitrogen weighs 14.01 grams. And 3 moles of hydrogen times the mass of a mole of hydrogen. And units work out. Now, on that one, it would be fair to argue that this 3 is the last significant figure. If I carry that extra digit in a calculation, it doesn't hurt anything. And in fact, if I round it off, sometimes that messes it up a little bit. It's just 1 extra digit. Let's just leave it alone. I don't expect you to put the units in like this all the time. I would like you to write these out, though, when you calculate them. And this would be the minimum that I would like you to write down. So this is for the nitrogen, and there's 3 for the hydrogen. You add them up, and you get this number. You should do that because we're going to be doing some calculations where calculating the molar mass is part of it, but really the point of it is all the rest of it. And so then if something goes wrong, you want to be able to look back and see, well, did I do that right? So the first step in checking this is just punch it through on your calculator again, make sure your calculator didn't lie to you. And if that's not giving the right answer, then look and make sure that you copy these off the periodic table correctly, things like that. We can use molar mass along with Avogadro's number to count or determine number of molecules in a particular massive compound. And so this is going to be the path, grams of A to moles of A to molecules of A, where A is whatever you're interested in. And so it'll write out in an equation like this. We got grams to moles to molecules. Grams down here, moles down here. That is just straight dimensional analysis. Yes.
Are we expected to memorize the moles to molecules, the 6.022?
That's a good question. Do you need to memorize Avogadro's number? I think I give it to you on the information sheet for this upcoming exam, but it's a good idea to memorize it. Yeah.
I was gonna say, is there any way we can see the information sheet beforehand?
Yes. In fact, let's just look at it. So let's do an example. Find the number of ibuprofen molecules in a tablet containing 200.0 milligrams of ibuprofen. C13H18O2, because I don't even know that formula off the top of my head. I think it's always a reasonable approach when you're given a problem to see if you can use dimensional analysis first. Some of them you can't, like, what's the name of HNO3? Not dimensional analysis. But a lot of the ones that involve numbers are dimensional analysis. So I read the problem, I'm going to highlight the numbers, it's just this one, and then I'm going to highlight what I'm supposed to find. Number of ibuprofen molecules. So I'm going to write this stuff down. I'm starting with 200 milligrams, and I'm trying to get to molecules. Well, what's probably going to show up in the middle? We're going to have conversion factor. It's probably going to involve moles, right? Do we know about a relationship between molecules and moles?
Yeah.
Mm-hmm. So that one's going to be Avogadro's number. And then this is a little weird. Milligrams, we were talking about grams to moles, right? But we also talked about milligrams to grams. So we could go milligrams to grams to moles. I'm going to show you a way that you can combine this into one thing. So this prefix milli stands for what? 10 to the negative 3. So what if I write 2.00 and instead of milli, I write what it means? Times 10 to the negative 3 grams. That's not proper scientific notation. You shouldn't write that as an answer. But does your calculator understand it? Yeah, it does. So there I just did that first conversion. It's kind of cheating. So now I've got 2 more arrows, so 2 more conversion factors. Oops. So I got to grams. I'm going to go to moles, to molecules. And then grams are down here, and moles are down here, and the units all work out. So we've used this in chapter 1, we've used this in chapter 2, we've used this in chapter 3. Guess what? We're going to use dimensional analysis in almost all the chapters. Okay? So if it hasn't become clear to you yet, ask me lots of questions because it'll make the rest of the class a lot easier. All the units in first. Now we need the relationship between grams and moles. They didn't give that to us, but they told us what the formula was, so we can calculate that. So let's show our work down here in case we screw up and need to fix it later. 13 carbon atoms. A mole of carbon is 12.01 grams. 18 hydrogen atoms. A mole of hydrogen atoms is 1.008 grams. 2 oxygens, 16 grams. .274. That's the mass in grams of 1 mole. Now, if we were doing sig figs, we could, think about adding, that should have 2 decimal places. It's not gonna hurt anything to leave the 4 there, in fact, it would be good. So I'm just gonna write the whole thing down. 1 mole is 206.274 grams. How many molecules are in a mole? 6.022 times 10 to the 23rd. So, now I'm going to use my calculator. 200.0 EE negative 3 divided by 206.274 times 6.022 EE 23 equals. How many sig figs should this have? Well, how many does our starting number have? 4. And Avogadro's number has 4. This is not exact. And this one will always, if you do it right, the molar mass will always have 4 or more, so you can just kind of ignore that. So we're going to go with 4. 5.838, that's 4. Write down 2 more digits. And then over at the far end of that number, it says E20, which means times 10 to the 20. So 5.839 times 10 to the 20 molecules. A mistake that students often make that my open math catches on your lab reports is you forget to look at the digit that you're dropping. This is 5 or greater, so I need to round this up to a 9. If you leave that as an 8, it's going to give you a red X because you should round it up. So just watch out for that. Any questions?
I have a question, but we already skipped over the part.
That's fine, we can go back.
When it says a non-hydrate, is there a different way of finding that versus hydrate?
So
What does it
a
mean?
non-hydrate or an anhydrate would not have the H2Os.
Okay, so it's just
So for every hydrate, there's an anhydrate without the H2Os. And most of the time you can get that one by just gently heating the hydrate. And the water will evaporate out of it. It actually looks like the solid is boiling sometimes. It's crazy to watch. But the water can go away, and that's one way to get the anhydrate, which
so the
is
only difference
not
is
a
it
hydrate.
wouldn't have the
The
H2O.
H2O part. Mm-hmm. Yep. Any other questions?